Hi friends, I just wanted to go into plasmonic metamaterials in this video and how they relate to the capacitor experiments that I've been doing and also to the Don Smith device. So what is a plasmonic metamaterial? According to Wikipedia, a plasmonic metamaterial is a metamaterial that uses surface plasmons to achieve optical properties not seen in nature. Okay, plasmons are produced from the interaction of light with metal dielectric materials. Okay, so that's a capacitor. A metal in a dielectric layer is a capacitor when you add another plate to the other side of that dielectric. So in and of itself, one plate and one layer of dielectric is a plasmonic metamaterial. Now, the light, okay, under specific conditions, couples with surface plasmons to create self-sustaining, propagating electromagnetic waves, okay, known as surface plasmon polaritons. Okay. Now, how do you create a surface plasmon polariton? Okay, so we go to the Wikipedia definition of it, and excitation. So how are these surface plasmons, these electromagnetic waves, how are they excited? How are they manifested? Because that doesn't really give a cause. They just say that they're kind of there. So surface plasmon polaritons can be excited by both electrons and photons. Excitation by electrons is created by firing electrons into the bulk of a metal. As the electrons scatter, energy is transferred into the bulk plasma. The component of the scattering vector parallel to the surface results in the formation of a surface plasmon polariton. You can see here's you get your light beam coming in, or whatever beam you have, electrons, photons, hitting the metal, and here's your dielectric media, and the surface plasmon right in between. Now, I read some papers on how these metamaterials can be used as waveguides for the surface plasmon polariton. And there are also excitons as well. So you got these polaritons and excitons that have to do with these materials that display a negative index of refraction. And that's one of the optical properties here, and we'll go back to the definition of plasmonic metamaterials, that they have a negative index of refraction. Okay, so this means that they filter light through it differently than others. Now, how does that relate to the capacitor experiments? Now, it's something called the Casimir effect, and this is an article by Scientific American that was published in Scientific American by Northeastern University experimental physicists Stephen Rucroft and John Swain. Okay, so they're talking about quantum field theory and how that vacuum in space is not empty. Okay, that it's full of these infinite modes of electromagnetic waves that can never be completely eliminated. Okay, so now we have a source. Where could these polaritons be coming from? Okay, because what do we have? We have two plates here, and what are they? These plates are actually mirrors. Okay, mirrors. So the mirrors will attract each other. You could look this up. The space energy on the outside is more than the space on the inside, and it pushes it together. Okay. Now, sorry for the shaky camera. Okay, so now these are mirrors having to do with light. Mirrors reflect light. So that's what the vacuum is. It's electromagnetism, right? Which is light. Okay, and so in our capacitors, okay, we're actually capturing these vacuum fluctuations by exciting the metal in the capacitor plate. Okay, and we'll go back to this one here. So basically, what's happening is that we have our capacitor here in our setup. We have our diode and our high voltage source. So this is one line of the transformer. One pole is going to one plate of the capacitor. The other pole is going to the other plate of the capacitor. And there is no closed loop in this. Okay, and we could see even that we're illuminating our light here. This is the Thomas Murray video. You can go back and check that one out. But in this video I show how adding the capacitor adds more energy to the system for the same amount of power coming into it. Okay, the thing is that here's the closed loop, is the spark gap. Okay, but until that occurs, okay, there is no closed loop. So the only thing that's occurring is that this switch is 100 nanoseconds, is 10 megahertz, is switching this power onto the plates, and that frequency is exciting the surface plasmon polaritons, just like the dynamical Casimir effect, okay, where the mirrors move rapidly together, right? They're moving rapidly. So that's all I'm doing, is I'm creating a resonance on those plates, okay, because that's on the diode, it's a on, off, okay, so it's creating a resonance on these plates of the capacitor, giving it a dynamical Casimir effect that's producing surface plasmon polaritons. Okay, and it's that energy that's going from this loud type of energy. Okay, this loud energy. Okay, maybe we could go back a little bit, but you hear that popping. Okay, and then the other way, when we turn it on,
all we're doing is we're using our...
Okay, and here, there's additional energy. So it's the same type of DC, high voltage DC type of spark, even though there's one diode in the circuit. Okay, it's producing more energy with the capacitor attached to it because it's releasing those surface plasmon polaritons, okay, down through the line here but it's out of phase. So when you go put a resistance on this, it doesn't do anything. It's all exhausted out of the spark gap, and only the transformer power is getting through to the load. Now, in some cases, like coils, we have our electric dipole moment interactions between different materials that have different electrons in their covalence. Now, I want to move on real quick to time reverse phase conjugation. Okay, time reverse phase conjugation, and this is a PDF by Sandia Labs. Okay, there's the web address at the top, and it's about plasmonic metamaterials. They're actually materials that have a negative index of refraction. So the light in a regular mirror is going to go this way and bounce off. A phase conjugate mirror is going to make that energy go right back down where the original beam came from. So what's occurring is that in the capacitor plate, we're getting our excitation from the transformer here, which doesn't do anything. It's not going anywhere. It's just sitting on this plate, vibrating this plate. And then we get the surface plasmons coming right out of space-time from in between those plates. Okay, and this is a whole awesome experiment here that they did. So I recommend you reading it to its fullest extent to understand how time reverse phase conjugation works and materials that have a negative index of refraction. Okay, we're not going to go all the way over that video because this over this paper because it's not the focus. Okay, so we've shown how by using the Casimir effect in these foil capacitors. Okay, that's an aluminum foil with a mica insulator and another piece of aluminum. So there are two plates with a piece of mica insulation in between, which by definition is a plasmonic metamaterial when it's excited, okay, by electrons being fired into the bulk material. All right, so that's where this extra energy is coming from. Okay, it's actually coming right out of space-time, and it's the electromagnetic fluctuations that say, oh, it can't be tapped into at the top of this here, which seems really ridiculous because once they start vibrating the mirrors, it turns into a real wave. Okay, and so they kind of contradict themselves in this paper, but so how does this relate to the Don Smith device? Because obviously, okay, the Don Smith device uses capacitors here, right? It's using a high frequency unit, okay, with high frequency diodes, okay, to excite a large amount of vacuum energy into these capacitors. And then in order to get it out, because it's called reactive power at that time, and in order to get it out, what you have to do, okay, and it's really minimized here, but you have to shunt the capacitor. Okay, you have to shunt it so that it blocks out the forward wave coming from your transformer. The thing, and actually I think this is more appropriate here. Okay, so here's the shunt. Okay, you have a shunt and then you have a voltage divider here that brings the voltage down after you rectify it again. Okay, you bring it down to lower voltage, you rectify it, and actually that's what this shunting here is it's to block out the forward EMF, because you're only getting this back EMF from this capacitor because it's the time reverse wave of the forward wave coming right out of space-time. That's basically the secret to the Don Smith device, is the plasmonic metamaterial that the capacitors are made out of. Okay, and then that's why he never shows how to use the energy, though. Right here, that's the big secret. How do you use the energy? Well, you have to put a resistance on it. You have to block out the total energy coming from the forward EMF from the transformer. And what that does, okay, is when you block that out, it allows the amplified wave coming from the capacitors to overcome the resistance that is happening with the forward EMF. And since it's out of phase, right, this energy from the capacitor is out of phase with the forward EMF, it doesn't interact with it at all. Then you can then use that and switch it in after you do a voltage divider and rectify it, you switch it in your transistors through your bifilar coil step-down transformer. Okay, and that's how you tap the zero-point energy. Okay, you're using the dynamical Casimir effect with phase conjugate mirrors, these phase conjugate mirrors that are caused by exciting plasmonic metamaterials with your electrons, okay, from the wall. But there's no closed system, okay? You're taking, with the Don Smith device, okay, from the capacitor and your shunt, this is not the right one, from your capacitor and your shunt, here, and your voltage divider, okay, you're blocking out the forward EMF. You're getting the amplified wave coming from the capacitors, which are coming straight out of space-time. You're literally isolating the electromagnetic wavelengths that are between the capacitor plates, and those capacitor plates in those capacitors, okay, they're very close together, so they're isolating very high frequency energy. And so in order to step this down, okay, you have to use a met glass transformer. And I don't know what just happened here. Oops. Okay. Just you have to have a met glass transformer core here in order to be able to withstand the high frequencies coming through. And this transformer, okay, is going directly to the ground. So it's coming off kind of like as Avermenko plug type of thing, and it's one of the wires is going positive straight to ground here. Okay, so you got one wire coming off of the capacitors basically, that's getting split into two. It's being alternated here, right? And that way you never have the discharge, okay, that's so violent and harmful to electronics. Okay, you can't control this thing. You have to alternately discharge the surface plasmons from each plate. You're just alternating them, you know, from each pole of the capacitor. And you set it up at 60 Hertz so that you could run motors and stuff like that. But you're pulsing a high frequency electromagnetic wave that's coming directly from space, from the capacitors. Okay, now this is the secret to the Don Smith device, and this is how you tap zero-point energy, is with plasmonic metamaterials. Okay, these are materials that achieve properties, optical properties, not seen in nature. Okay, so you're not going to find these physics in anywhere but places like these deep black, like the Sandia Labs. Okay, and we got tons of videos out there on, you know, all the missing money that's happening, and you know, this is where it's going to. It's going to these experiments. So, you know, I think that a lot of electrical engineers are highly confused about what's going on in my experiments, and even just researchers in general who look at my experiments and say, "Oh, that's just a high voltage DC, and discharging. It's like a Tesla coil. The old school Tesla coils work like that, or what do they call them? Those electromagnetic cannons." I can't think of it right now. But you know, people always think that that's the only thing that's going on here. No, you can do more than just discharge this capacitor through a spark gap into a load. You're never going to get any more energy out than what you put in doing that. Okay, first of all, you're creating an antimatter explosion right here, which is putting off all kinds of X-rays, and you could see the cavitation, that blue ring around. That's radiation. Okay, it's a safe level of radiation, I would say, but not for prolonged experience. Not for having running in your house. So anybody who I see doing the Don Smith device with these spark gaps, you're not doing it right. Even though he did say that you could do it without the spark gap, he meant not do it with the spark gap, because you're wasting the energy. You're creating resistance here, and instead of with this setup, you're creating resonance, right? On alternately here in your inverter device. You're not ever, this side is not ever touching to that side. Okay, it's all just going to ground. It's discharging positive to negative, positive to negative, positive to negative. Okay, like you would on a regular transformer. You're not arcing the capacitors together. Okay, there's no spark gap here, right? He's just putting his bridge rectifier and shunts and everything, voltage divider, and his transistor circuit on the other side. There's no spark gap here. So I didn't realize this for a while because I wasn't researching the Don Smith device or trying to accomplish it. I was, working on quantum gravity, the Townsend-Brown, Biefeld-Brown effect, and high-K dielectrics, similar to the Kautsky-Frost experiment. So they're not those triangular ionocraft. Those are not the real Biefeld-Brown effect. Well, it is, but when they put the lifter in vacuum, they take out the dielectric, which is the air, which is the propulsive material that's actually producing the force in the lifter craft. So when they do the vacuum experiments, they're actually taking out the operating principle from the craft and then calling that science. It's pretty ridiculous. So just like with how these capacitors are filled up with high voltage DC, it's not true because there's nowhere for them to fill to. Okay, in my experiment here, there is absolutely no let me try to get that. There is no there's no ground wire. It's just one wire to here, the other wire to there. Okay, and then you can arc them together because surface plasma and polaritons and excitons are quasi-particles that are pretty much antimatter. Okay, and so when you collide them together, they create a supernova explosion, and I explain this in my paper on the New Energy Concepts group on my the pulsar experiment report about how that's all it's all a cosmological phenomenon going on here right here on the lab bench because it is the same space energy that is out there in space. It's just on a different scale. So anyways, I'm trying to make this video pretty quick for you guys so I don't bore you all to death, but I really want to get this conversation going about plasmonic metamaterials, how they can be used for not only filtering out energy in spacecraft from the Van Allen belt radiation, okay, because it can refract the electromagnetic waves differently and actually could be used to power the ship through the Van Allen belt radiation, but also how this is the way that Don Smith was tapping the zero-point energy field, was with these capacitors here. It has nothing to do with the coils and all that's a big distraction. Okay, when he's very quiet about these capacitors because honestly a lot of these metamaterial type things and everything, they are government projects. They do have to do with government technologies, and a lot of them are classified. So you don't really see you see the time reverse here. You don't really see this discussion happening in the mainstream, even though you can link the capacitors right to our metal dielectrics. Okay, and there's it's not just metal dielectric, but it's metal dielectric metal insulator metal, and different configurations of metals and dielectrics that make different properties for these surface plasmons. Anyways, so I just wanted to show how plasmonic metamaterials are these foil capacitors and how they relate to my experiment, the Don Smith device, and eventually we'll get into how they're used to create gravitational fields and forces, and basically to process the electromagnetic media of space-time in a way that makes it so that you can actually process this space through a material in such a way as it propels it. And that's what, Thomas Townsend Brown's work was on, and we'll do another video on that, but I just wanted to focus on the Don Smith device, my experiment, and how it relates to plasmonic metamaterials, the dynamical Casimir effect, and surface plasmon polaritons, and that this is, it's this wave from space here, okay, that's being isolated from space, that is the 0-point energy, and that's how you tap it. You tap it with a high frequency diode, okay, on your capacitor, vibrating those plates of that capacitor, then suck out the space charge that's sitting right here in the air, okay, and I just don't want any confusion about how to tap the 0-point energy field, because or how it's used, because there's a lot of misinformation out there on these DC capacitors and these spark gap experiments, and there's a lot of confused people that are not looking at the physics. Okay, the physics are there. This is on Wikipedia. Okay, it's out there right in front of our faces. You just have to learn how to put it together. Okay, and a regular electrical engineering was developed by J.P. Morgan. Okay, so you would never ever find these things. And then these two fields were split apart so that if you're an electrical engineer, you're not also a physicist. Okay, for the most part. All right, but I've had to teach myself all of these things in order to be able to explain to myself what's going on in these experiments, because traditional electrodynamics just was not cutting it, especially electrical engineering. This just doesn't, it's just not out there, okay? So this is my attempt to put this out here to correct the misinformation that's going on about these different technologies and how exactly they are actually working here. Alright, well that's me for the New Energy Concepts Group, signing out.